Hello, viewer / listener. Welcome to Break, Fallthrough aftershow. This is Break for Fallthrough episode 56. And Dylan had to run, so it's just Steve and me. It's a little two panel little after podcast.
Yeah.
How do you feel that episode went, Steve? What are your thoughts? What are you feeling?
I think it's pretty good. I think that like many episodes, we talked about Gastown a medium amount, but not all of the time. And so that's like both good and bad. Hopefully people enjoy where the tangents went, even if it's not necessarily exactly on the topic. It definitely was like related enough that I feel like it's coherent, but it's also, yeah.
Yeah. I mean, the point of the podcast is to be nuanced, so I don't know if you can really be nuanced about it. I mean, it's like, oh, we're spending $5,000 on Claude Code instances. I'm like, or Claude instances or subscriptions. I'm like, I don't know if you can talk about that and then not talk about like data centers and power and water and a whole bunch of other things that are like, important to consider when talking about all of this.
Yeah, absolutely.
But I do feel like there was a good amount of nuance there, especially in that discussion of data centers and whatnot. I think it's good to have wider context so we don't get hyper focused on data center bad. If we got rid of data center, everything would be good. It's like that's not real. That's not realistic.
Yeah.
Things would still be crappy even if we stopped building so many AI data centers.
Like, why we don't have famines anymore? Because we like got good at telling what's happening with the weather, and we got better at logistics, and like all that stuff relies on computers. And if you want to like go back to the before times, like it was not universally better. Like a lot more people died for a lot of reasons that we didn't need them to die anymore. And so I feel like some people's opinions have gone way too far in the opposite direction, which is like, yeah, there are problems, but like the Butlerian Jihad is like not the correct move forward here. Like,
yeah. There's a lot of desire to throw out the entire system because there's like a few things wrong with it, which is, I mean, ironically, how we tend to think about software a lot of the time. Like we as software engineers tend to rewrite systems when there's like, I don't know, 30% of it is annoying us. And I'm like, okay, well, you threw out 70% of what was working and now you got to go rebuild that 70%. And you're certainly not going to do that correct. So I feel like it's in our nature to make those stumbles a little too often, I think.
Yeah.
But, building software is tough. So I get why people kind of lean toward struggling with it. One of the things, so I'm doing like this project. So we were talking about, before we started recording, we were talking about semantic versioning and versioning and all of this. And one of the things that I did, I want to do a full version of this by using the Go module proxy, but I did like a preliminary thing because I have this theory where I'm like, I don't think that a substantial amount of code changes between major versions, right? I was like, I don't think that it's like 80 or 90% of the code that's changing. I think it's like maybe 30 to 40% of the code that's changing. So I did a little audit of some random modules, some popular modules, and it turned out a lot of them are not changing much between major versions.
Your idea was right.
Yeah, and it's interesting because even the ones like the Redis module for Go is actually a pretty good example of like them actually ticking up versions because they're V9 now. So they've kind of been progressing forward. And like the difference, I don't remember if it's between V7 and V8 or V8 and V9, but it was one that had like the biggest breaking changes to it, where it was like, I think like 80% of the surface, API surface had broken, but those breakages were all adding context as the first parameter. So all of those breakages are completely automatable fixes. So it's like, okay, but this didn't actually like really semantically change the package. Like it technically, yes, it's a breaking change, but like that's not necessarily something we should really consider breaking. I think that's like, what is breaking depends on what are your tools. Like, can you automatically migrate code? If you can, it's no longer breaking, is it? So I think there's like, it's interesting, but I was happy to find that like my theory was correct, at least for this small sample. I have to do the bigger evaluation. Then also I want to do some amount of like what symbols are actually used and weigh that into how much of the API surface is changing. But like, I have this belief now that like differences in major versions are not what we conceptualize them as, mostly because semantic versioning states a lower bound, right? It's like something has broken or a thing has broken. But I think people interpret it as an upper bound of everything is broken.
Right.
Which I think is part of the disconnect that we're all having with how we use semantic versioning.
Yeah. There's definitely a sense of where like the zero tolerance for breaking changes is both like correct and also unnuanced enough to make it like harder for some people to get on board with making major version changes, because it feels like a big thing. 2.0 feels like, and 1.0 both feel like massive important things, and not just like, oh, there was a small backwards incompatibility in this one module and therefore the whole thing is considered breaking, and so now we're doing this. I'd also be curious if your analysis holds across language ecosystems too, because I feel like Go is specifically like has a culture of trying to reduce this sort of breaking change, and other ecosystems do not. And so I'd be curious how much that like is a secondary effect.
Yeah,
so, Go.
That's one of the things about Go that I think with modules I was disappointed with. Even with Dep, I think looking back in retrospect, I'm disappointed with the direction both those took. Because even with Dep, it was like, oh, let's do the thing that everybody else is doing, which I think is fine for most languages. But Go sat in this really unique place where we just have had for a very long time, for basically the entire existence of the language, or at least the post 1.0 release, extremely good static analysis tools. And the language is designed in such a way that you can use static analysis tools to actually understand what the code base is doing, or even what libraries or what any of that is doing. So it's like, and it's built into the language. So it's like unfortunate that we took the path that everybody else was taking, who don't have the same level of like introspectability, or at least didn't at the time their package managers were created, that same level of introspectability into their code. Like if you can't actually analyze the code to see like, what kind of breaking change is this, then you just have to treat all the breaking changes the same. But we already had Go Fix to do automatic code migration. So it's like, well, something as simple as adding a context is something that you can do mechanically. And we've had multiple tools that do those mechanical transformations for us. And that massively reduces what a breaking change is.
Yeah, definitely. It's kind of, in the episode, I had made reference to sort of like revisiting core assumptions because like of what they are, and the idea that breaking changes are like very difficult or like hard or bad or whatever stems from things like, now I got to update all my code to use the new APIs, and if it was like run this command and it will automatically losslessly fix that, the cost changes significantly, and therefore the like, is a breaking change a big deal equation changes significantly, and that just really depends on the rest of the context around the thing that you're building.
Right.
And yeah, and there's like other ones too, like, you know, for C libraries, it's like ABI is a big deal. It's like, you know, if you like breaking changes are a bigger deal because you may not have the source code for the thing that you have, the binary you have anymore. And so you can't make breaking changes because you just like cannot regenerate the source code. And that kind of trade-off in that environment is totally different than one in which you have all the code, it is trivial to update, and it's like, you know, not like a reworking of the entire universe, but a function that has 3 parameters now takes 4. And like, you know, the new parameter is like, can default to true in 99% of cases. And so it's like fine, or like whatever.
Right.
Yeah.
And like other languages have things like default parameters too, that make it so, you know, you don't, even if you add a parameter, that doesn't necessarily break older code because they just get the default. So like each language is different, and like what breaking is in that language is different. So it's been fascinating doing this research, because it's like things are a lot more diverse than I think people would initially think, and especially if like you kind of enter the industry like around the time I did in like the early 2010s. A lot of the stuff that's there feels like it's been there forever, but a lot of it's like very new.
Yeah.
Because like when I started writing PHP, we only had pair. We didn't have composer and packages. So like package management was like not a thing, but it also didn't really need to be a thing because you were probably working in some framework where it had like a module system like Drupal does, or a plugin system like WordPress, where you just grab them from somewhere and install it, and that's how you get more software, get more features or whatever. But you know, having composers really nice at the end of the day.
Yeah. Now I'm like, how old is pair? Because I feel like it existed.
Pair is really old.
Yeah, I know, but like I was writing PHP in like 2008, and so I remember pair existing, but I don't like. I'm like, was it new while I was like doing
Pair,
that?
I think, was
like,
early 2000, so like 2003, I want to say maybe.
yeah, pair 1.0 was 2002.
2002, yeah.
As a PHP 4.3, pair is officially supported part of PHP. So yeah, absolutely, that like existed at the time.
Yeah.
That's cool.
The whole history of this, and like I find it fascinating that it all started in the 90s. I had a theory that actually proved to be incorrect, whereas like I thought that language package managers evolved out of operating system package managers, but they actually developed at the same time.
Yes.
So you get Perl's CPAN at the same time as you get the Debian's dpackage or whatever. Yeah, apps basically. Like both those things developed like at the same time. Interesting, CPAN is off of the tech archive, which is like CTAN, and you're like, wait, LaTeX started all of this? That is insane. But that was like the genesis of all of this. I'm like, oh, and like the way that the two like operating system and programming language package managers are completely different beasts, I think is also something that's like lost on people. Because with an operating system, right, like with Debian or with Ubuntu or with any of them, like you control the thing. Like they do have a small number of targets, and you control what goes into the repository, so you can have the stability guarantee, which is like why so much stuff in like Debian and Ubuntu default repositories is so old, because they actually have humans testing everything to make sure it's all compatible at the end of the day. Whereas like that's not a really tractable thing to do for programming languages.
Yeah. And also, there's also just the feature differences that happen too, because like a lot of the OS level package managers were designed around like C's compilation model and C's dependency model, and also like assuming that you're building like an instance of an operating system. And so like the one version of a package in the entire world was like made sense in the sense of like I'm trying to build a Linux distro image, but like did not make sense in the like I am a consultant and I have a client who uses Ruby 2 for one project and Ruby 1.8.7 for another project. And I need both of those to be installed and usable on different projects. And then language level package managers were like, I don't know, man, this is not how this works. And so that's like part of it too, is that like that gap, even though they started at the same time, they based themselves off of different requirements. And that meant that they ended up going in different directions and had different features because they had like different base assumptions of how things are working out. And like, you know, people got mad at us in Rust for being cargo. Is like, why can't you just use a little package manager for your system? And it's like, I'm a Windows user. I do not have a package manager for my system. I would also like Rust programs to work well and like this kind of thing. And so at some level, like the proliferation of language package managers is because they're trying to paper over operating system differences, which like by definition, the operating system package manager cannot address. Like you are not using Debian packages on Windows definitionally. So like, you know, and that's fine, but it just also means that like the operating system package manager is not appropriate for application level packaging concerns. They're just two totally different tools that happen to be similar problems and are named the same thing, but they're not really replacements for each other.
Yeah, exactly. I also found it interesting in my research when I stumbled upon, because I was always confused why yarn was created, because I was just like, wait, what's wrong with npm? But in this research, I'm like, oh, npm like just did not respect lock files properly, even once it tried to put them in. And like yarn was like, hey, let's have lock files work. And I was like, oh, this all makes a lot more sense now as to like why we needed this newer, like a newer way of doing things, or a newer package manager, really.
Yeah.
Like it's so fascinating, actually, like looking at this history and being like, oh wow, this is pretty cool. It's also like part of me is like, wow, modules feels so distant from like what Go was before, where Go, like there are a lot of Go packages that are, I think still are in like Debian's apt repository, right? And you can like install and use them. And I was like, why would you want that? Why do you have that? And then I was like, oh wait, that's actually like a useful thing if you are just on one system, to be able to just use your operating system's package manager to get your dependencies. And it was like one of the nice things about the GOPATH era of Go is that the build tool did not care at all how the dependencies got there. So you could use whatever dependency manager you wanted, and you weren't forced into like using the toolchain's ideology of how to manage your dependencies, which gave like so much freedom, and I think was a really untapped potential of Go. That's like, I don't know if it's possible to get back to that, but like I think having the optionality to use your package manager, your operating system package manager if you want to, or use something else, is like the kind of flexibility that we want in the world more.
Yeah, totally. I think it makes a lot of sense. I think the other part, these allergies. Nope, not gonna actually sneeze. I don't know. Like another related part of this too is that like those packages exist because like Debian's view is that apt is really for how you build Debian and what's part of the like base system. It's not really fully intended to replace what users want to use for all of the, like for what developers want to use on top of their stuff. Like, and so like a ton of Rust packages are packaged in Debian, but the reason they're packaged in Debian is not because it's ever expected that you'll really use those to build your applications. It's because there are Rust programs packaged in Debian, and those packages need their dependencies to be packaged as well. And so they're there because they're there to serve the programs. Like ripgrep is like in Debian, so therefore ripgrep's dependencies need to be in Debian. So like they're not really trying to like replace crates.io with having every version of every package ever that you may want to use. It's purely about like, here are the programs we need and here are its dependencies, and that way they can dedupe those dependencies across the programs, because again, that's like one thing they're trying to do really hard. And so, you know, that's just like also part of it too, is that I think that a lot of people put sort of a lot of people blended the lines between the package manager for the system and the package manager for my applications, and sort of relied on the ambient installation of like, oh, the packages exist on my system and therefore I can just use them in a way that's like not really what these tools are intended for exactly, but it worked well enough for most things that people did it for a long time. And then just eventually we see the limits of that model.
Yeah, I think too, it's like, it feels like we're in a place in the industry where we actually should probably start rethinking a lot of the ways that we do dependency management. Because it's, you know, a decade ago, or maybe like 15 years ago, when like there really weren't like the ability to actually look at the code and understand what's going on. But I feel like pretty much every language now has some form of having like more static typing to it, where it's like you can actually tell what types are going where and what symbols are being used by dependencies and applications and all of that. And that kind of changes I think that changes the narrative about how we should look at dependency management as a whole, not looking at it at like the package level or like the module level, but looking at it at like, you know, a symbol level or something much more fine-grained than what we currently look at it as. And I think that there's like a lot of interesting things that follow from that, which I think would give us more robust software at the end of the day.
Yeah.
And perhaps a better supply chain as well, because I think our software supply chain is a mess. And that's like one of my criticisms of MVS is that like the Go team's perspective is, well, newer, like you might get some brand new code that has all these vulnerabilities in it. And I'm like, I haven't confirmed that all of them, but I feel like a significant number of vulnerabilities are because old code, not because new code. Yeah. So it feels like a thing that keeps us on old code exposes us to many more vulnerabilities than something that pushes us to new code.
I feel similarly about the like, we'll just wait to use the package for a month and then all the bugs and security vulnerabilities will shaken out. And it's like, if everyone does that, then the benefit goes away. Like right. The reason those vulnerabilities are found is because people actually use the code and then they discover this is the case. Like,
we are much better as an industry at finding vulnerabilities and exploits in new code than we are at finding them in old code. But also the nature of it is that there's way more old code than there is new code. So, and that and vulnerability. I mean, look, Mongo had a vulnerability they found that dates back like nearly a decade. That's like, you basically can just like read random memory without authenticating. And it's like, yeah, no, that's not great.
Not ideal.
And it's like, we keep stumbling. I mean, React had the React to Shell, like a couple months ago, where it's like, oh yeah, in some React server-side deployments, you can just get remote code execution. Of course, there's also log for shell. There's like a whole bunch of these things. It's like, yeah, this affects like a huge number of versions. And if your version resolution system keeps you on old versions instead of pushing you to newer ones, then it takes more time to like get away from the vulnerable versions of things. It takes more takes more attention from users to be like, oh, I should force the system to give me a version of this dependency that is not vulnerable, instead of the ecosystem just pushing you to do that anyway. But the thing I do like about Go modules is that it did try to do something different.
Yeah.
Which I think is good.
Always. Like, there's definitely value in experiments, and you learn what's good and what's bad about them. And, I think that there's a lot of good in it, as well as some stuff that is find a little more personally questionable.
Yeah, a lot of us have our gripes with it. But I will say that I'm glad that we at least tried something. Perhaps the trying could have gone a little better, but we tried something. And I think it's time at this point where we start trying new things again. That's one of my projects for this year, is to try a new thing. I have this alternative Go Toolchain that I've been talking about for a few months that I really want to build. So hopefully 2026 will be the year that I can actually build it and show it to the world. And maybe it'll be that pivot point where everybody's like, hey, that's a cool idea. Let's all go in that.
Yeah, nice.
But yeah, we'll see. Yeah,
exactly. It's easy to be optimistic in January.
Yeah, it's easy to be optimistic in January. It's easy to be optimistic when it's just me and like my close friend group that I've been talking to this about. And then you put it in the real world and you're like, oh, okay, people don't like that. Okay, great. Yes. But I don't know. I feel like maybe that's a good place to end. I know you got to run.
Yeah, totally.
So. But thank you for joining for break and being on the main pod. It's always great having one of our wonderful guest co-hosts, maybe one day a host. I don't know.
Yeah, we'll see.
We'll have to figure all that out. But you have a new job now. You have more time, right? You have more.
Exactly. I have even when you go to a small startup, that means you have even more time for things that are not work. For sure.
More time. Yeah. Yeah. What about you, viewer/listener? Do you have more time for things after joining a startup? No, I don't think anybody does. But how's your new year going? Why don't you tell us in the comments, social media, and how'd you like this conversation? It was a nice little thing. I think Steve and I really like talking about dependency management and versioning and all of this. So it's nice to have a little chat about that. And I hope you learned something about the history of dependency managers and like everything in tech. It's very messy. But with that, make sure if you aren't following us on social media, give us a follow. If you're on YouTube, hit that like button and let us know your thoughts in general about this episode, about Fallthrough, about all of it. Changelog Zulip, on Gopher Slack, or wherever you might find your lovely Fallthrough or Break post. This episode of Break featured Chris Brando and Steve Klabnik. Break is a Fallthrough Media production and is produced by Chris Brando, and our beats are by Breakmaster Cylinder. There we go.
Nice.